Yes, hello. I'm aware I'm the last person on the last day, so you will be relieved to know that there are lots of pretty pictures, and I'm going to start by talking about films. So there isn't any in-depth philosophy, and there are some ethical dilemmas, but I'm going to keep them back to the end, so you can relax for a good 20 minutes, half an hour. Okay, so as I was introduced, I work on the Human Brain Project. I'm the compliance manager. But before I was the compliance manager, I worked on research integrity for my institution, to Montfort University. So I'm going to talk a bit about research integrity as well, because I think young researchers and senior researchers should learn about that. But we've heard a lot about ethics and about transgressing research ethics. So what I wanted to start with actually was just talking about some examples from science fiction of examples of scientists who have really transgressed their ethical remit. These examples you're about to see definitely did not get ethics approval. So, to begin. So, this is a film called Splice. I don't know if you've ever heard of it. Don't watch it late at night. I still kind of get a bit uncomfortable thinking about it, actually. So, in this film, there's two scientists, husband and wife, and they are trying to do genome splicing. And they develop these sort of genetically engineered dogs. And they're told that they should just use this for commercial use. But they want to do something bigger. They want to change the world, right? And they develop this creature with genetic material. And instead of just, the husband's like, we should just destroy this, right? Before it gets out of hand. But they don't. And they take her back and they name her Dren. And they basically take her to this sort of secluded farmhouse and bring her up as something between an experiment and a daughter. And it all ends horribly. I won't spoil the end of the film for you, because it's not something that we should talk about probably in the middle of the day in a nice, with nice people. It's really quite grim. And also because, you should see this film. It's really good. But it's, the ethics of one, creating life, creating a creature that's never existed before, and also of not having that barrier between work and and home life, perhaps, to becoming too personally invested and not being able to see things clearly. So this is a more sort of this is a sillier example, frankly. So this is from one of the Spider-Man films. There's been, like 20? And this is, in this one, this scientist, he's got one arm. And he's trying to use, what are they called? Salamanders, right? Salamander DNA to work out how you could regrow limbs. But it all goes horribly wrong. And he ends up as a mutant crocodile, because that's how science works, obviously. But in that, again, he's told, you really shouldn't do this, but he's obsessed, and he lets his personal ambition get control of him. And I'm sure you've all heard of this one, right? And in this, again, creating creatures that maybe shouldn't exist. So there's Lion Man and Boar Man and so forth. I won't do the whole synopsis because it's a classic. The 76 version, not the 1996 version, please. And in this one, Dr. Alice Crippen tries to think she's cured cancer, viral cure for cancer, and she actually causes the apocalypse. So that's not great. Obviously, human testing went very badly wrong. So at the start of the film, we see Alice Crippen saying, yeah, essentially I've cured cancer. And then the next thing we see is like New York decimated and Will Smith being chased by vampire zombie hybrid things. I didn't say these were sensible examples, just said they were examples. And just mainly because I need an excuse to talk about dinosaurs. So Jurassic Park. So this is an interesting one because we see the genetic experiments here, But we also see the scientists going, this is a really bad idea. The three scientists actually say at the start, this is going to go horribly wrong, which it does. But what's interesting is actually I attended a talk at a conference last month, and they can't bring back dinosaurs, sadly. I mean, which is quite correct. But they can do what's called genome drives, and they can do reverse extinction. So there was a type of goat that was extinct, and they managed to bring it to term, and it lived for like, I don't know, 8 minutes or something. But they can actually do it if they've got enough of the DNA. They haven't got enough of the DNA of the dinosaurs yet. Yeah, so there was a whole thing about woolly mammoths, absolutely right, Christine. But the problem with that, ethically, well, there's many problems with that ethically, but it doesn't help conservation. So all the things you need for conservation is protecting habitat, ensuring food supply, getting government buy-in. Bringing back more animals doesn't solve any of those problems. It just creates more animals for which you have to conserve. So this guy was saying that this is not a solution. This is just fancy science, which makes great headlines, but not necessarily going to actually help us. But the point of all these is the horribly wrong, right? So these are big, dramatic transgressions of ethics. These are large-scale. One person ruined the world. They literally, caused the apocalypse. And these are large-scale, and they always get punished for it, right? They always kind of end up dead or horribly sort of mutilated or what have you. But that's not what it's like. That's not what ethics is like. And that's not what science is like. I can tell fact from fiction, I do assure you. But science fiction, good science fiction, those are silly examples, but there are better ones. Ex Machina would be an excellent example of a thoughtful science fiction film. So science fiction and ethics, they both examine the consequences. They both ask us, what if? If we do this, what happens? They look at our fears and our expectations. So my PhD was on the fears of technology, which is, quite fitting, really, considering what I do now. So it's not quite as big a jump as it sounds when I was introduced. So the fears and expectations. So the fears are, what if, care robots kill my gran, Or what if a scientist H5N1, right? What if they create some virus that kills us all? But expectations are, do I really need to learn to drive? There'll be self-driving cars in, a couple of years, right? Do I need to is this going to solve my problems? Or, I don't know, 3D printers, right? So we were talking about citizens engaged in science, and I went to an event about part of it was about citizen scientists. And one of the things I remember is that so in developing countries, they can't afford prosthetics. And people have taken 3D printers and they've printed 3D prosthetics on a mass scale and taken them over to these countries where they don't have a health infrastructure and given them to people who need them. That's amazing. That's technology infinitely improving our lives. These are the kind of expectations we have, but we also have fears. And I think this was picked up on. There's both bad and good. There's always a cost and a benefit. And this is a theme. That's the trouble going last. Everyone said everything. But this is a theme that we've talked about throughout this conference, right? Cost and benefit. The cost of hurting animals when you do experiments on them versus the benefit of creating a new drug or a new solution or a new understanding that will help humanity. So ethics is about weighing that cost and benefit. But it's often on increments. These aren't big, this isn't, do I risk becoming a mutant crocodile in order to regrow limbs? It's increments, it's small margins. So I want to talk about smaller acts, as demonstrated by the adorable chihuahua. So this is the consequences of cutting corners, of cheating a bit, of you know, ignoring something. And these combine, or sometimes on their own, but they damage research. And they damage research, and in a cumulative effect, can do damage as dramatic as those examples I gave. So some examples would be falsification, or fabrication, or fraud. So if you pretend that this immunization that you've just developed, and you falsify that, and that's used, that's really dangerous in itself. But also, and I'm going to talk more about this, even in, say, the social sciences or something, where there may not be a direct physical effect on people, you damage our understanding, you damage the knowledge base by these smaller acts. And so conflict of interest, that sounds interesting, right? Everybody suddenly sat up and took notice when I said conflict of interest. But one of the most famous conflicts of interest was Andrew Wakefield. And he had a conflict of interest in that he was being paid by lawyers to find that the MMR vaccine, the vaccine that they give children for measles, mumps, and rubella, was dangerous. So he said it linked to autism. And now we have measles come back. Children have literally died because this man had a conflict of interest. Now, okay, that's an extreme case. That's going back up to dramatic stuff. But the consequences are still being felt. I think France just decreed the other day that they're not going to allow parents not to vaccinate. I get quite angry about this, so I'm going to move on before I start getting ranty. But you know, this is sometimes what seems. I'm sure Andrew Wakefield didn't wake up in the morning and went, I think I'll bring measles back and kill a few children today. No, he went, the money's really good, and what harm will it really do? And I'm not a bad person. No one thinks they're a bad person. You know, everyone thinks they're justified. Okay, so sorry, I'm getting judgmental. I'll stop it. We'll move on. Okay. So this is where research integrity comes in, right? This is more about the smaller acts. This is about day-to-day research. So it's a good decade now that research integrity has been part of research culture, part of science. So it's good research practice. We heard a little bit about that yesterday. So it's conducting research in accordance with the principles of honesty and rigor. The Singapore statement was made at the Second World Conference on Research Integrity in 2010. And that was the sort of basis from which research integrity has emerged. And since then, there's been the Universities UK Concordat to support research integrity, which is kind of semi-mandatory for all universities in the UK to sign up for. And we also have the UK Research Integrity Office. The Office of Research Integrity in America dates back to the 80s, yeah? And they actually have a federal power, so they have teeth. Actually, though, there's no evidence to suggest that one is better than the other in terms of actually stopping research misconduct, whether voluntary or top-down. And then the European version, which probably most relevant to you, would be the ALIA, all European academies. So European Code of Research Integrity, all the links are here, so if you have interest in reading policy documents, I know I do, my favourite thing to do is you can go and read through them. But the gist of them is going to be covered by this talk, hopefully. So that's the history. But the point of kind of going over these things is to tell you that this is becoming something that's more and more part of governance of research. So it's not just the ethics committee anymore. I think it could be Denmark that they recently said that some parts of their research integrity, some parts of their investigations of research fraud will actually be state legislated, and some will be kind of on the basis of their institutions. Now, one thing that I often get asked, and I think is really important to point out, research integrity, or rather research misconduct, is not about differences. Poor practice does not include differences in the design, execution, interpretation, or judgment in evaluating research methods or results, or what might be deemed academically poor research. If your research is rubbish, that's not misconduct. If you're a bit weird and you think differently from your peers, that's not research misconduct. In fact, Innovative research is what we want. We want people to think outside the box. We want people to think differently. I am against anything that curtails that. But, you know, so sometimes it's misinterpreted that research integrity is like, oh, we all have to be the same. We all have to do things in exactly the same way. But that's simply not true. So I think get that out of the way. Another question I often get asked is how is research integrity different from ethics? Well, obviously they overlap, right? But put sort of fundamentally, integrity is about the quality of research practice, as I said, on a day-to-day basis and its results. Whereas ethics is more about the protection and well-being of humans and animals involved in research and the results thereof. So ethics is something you think about in terms of ensuring that your research doesn't cause harm, whereas the integrity is more about thinking about, is your research actually are you doing research in a way that best benefits both, you know, yourself and society as a whole. And ethics is, I always think in my head, ethics is sort of quite sharp in terms of, you know, you put in an application, you get approvals, whereas integrity isn't kind of regulated in that way. Integrity is more about kind of actions on a smaller scale, which is why I'm trying to talk about dramatic and smaller acts. But I think it'll become fairly clear what the difference is as I go on. Okay, so why do we need research integrity? So I don't know if you can actually see that, but it says, go ahead, don't think of it as plagiarism, think of it as a homage, which is quite nice. Okay, so why do we need research integrity? Well, academic pressure. We've heard the phrase publish or perish, right? We have institutionalized sloppiness. I think that was a point raised when we talk about animal research. So this isn't malicious intent. Well, not always, but it's a culture of yeah, just get the results. Just I don't want to know how you do it. Just get me those results. It's a culture of, well, you know, he published it on a blog. I mean, that doesn't count, right? You know, that's not really plagiarism. I've got to get this grant. If I don't get this grant, I'm not going to get a tenured position. I'm not going to get my postdoc, whatever. You know? So I'll just I'll claim I can do anything, and we'll worry about it once I've got the money. It's that, okay? It's the fear of failure. Hands up who has a fear of failure? Yeah, okay, good. I was really hoping my hand wouldn't go up and everybody else would just sit there going, no, I'm perfectly comfortable. So it's the fear of failure. And I think, in a way, the fear of failure is worse the earlier you are in your academic career, because it's like being a teenager, right? So when you're a teenager, everything's horrible because you've never experienced it before. And so you don't have that context to say, actually, this will pass, this will get better. So when you're starting out in your academic career, it's all fresh, it's all new wounds, and you haven't scarred up and gone, yeah, okay, so that was a scathing review of my paper, but that happens to everyone, you know. That's just par for the course. So it's this fear of failure is strongest perhaps at the beginning. And fear of failure can drive people to do very strange things, including maybe making things look better than they are. So we have a reproducibility crisis. So economics, psychology, and I think even some of the life sciences have a reproducibility crisis. And what that is that experiments have been done, they've been published in journals, but they can't be reproduced. The results don't come back the same when another scientist does it. Now, this, in psychology, of course, are two groups of humans ever going to react the same way? So, you know. But anything with more hard data should be reproducible. Now, we had attended a fantastic talk just now. And one of the ways you can get around the reproducibility crisis is by publishing all the data and making that available. so that it's clear what is your interpretation and what are the actual findings. But part of the reason for the reproducibility is that you just ignore that outlier. That doesn't really matter, right? You know, it's just ignore that. Just lady who's the Cambridge Cognition lady. She was saying about moving the end of the the end of the graph. Name's not my strong point. The end of the graph, right? To make it, you know, a bit stronger, a bit weaker, whatever. That kind of thing. It's not terrible, you know, but it's problematic. And going back to this idea of research misconduct undermines the knowledge base. So everything we do, unless you are very, very, very brilliant, and even then, it's built on what's already gone before. Okay? So when you do research based on what we already know. You might test things we already know, I admit that, but nonetheless, you're still basing it on what we already know, whether or not you want to build on it or test it. If what we already know is based on poorly done research, not in the sense of bad research, but in the sense of wrong research, as in falsified or what have you, then you're building on a house of sand. So how can we expect to further knowledge if what we're furthering is fundamentally misplaced, is mistaken? So I think that's, to me, is actually one of the strongest arguments, is that if you care about your subject, if you care about furthering human knowledge, which I assume you do if you're in this room, then you want to ensure that the research that you and everyone else undertakes is of the highest caliber, is of the most exacting that you can possibly do. And again, this, I think, is an argument for open science. So research integrity and open science, I think, are you know, they're connected. They're very connected. I think one is, in a way, part of the solution to the other. So that's enough fear-mongering and lecturing. I do apologize. Benefits of research integrity. So it's to protect researchers. So many people, when I was doing my old job, have come to me and said, I felt pressured to put my supervisor's name on a paper that he had nothing to do with. Okay, it's not the end of the world. You're not going to, you know, it's not going to ruin your career, but it's not fair either. No, okay, I know in some subjects this is just expected norms, but in others it's not. So this is part of the problem with research integrity. This is why it's difficult, because subject norms differ. So this is particularly junior researchers. They often are pressured to get results. They're often left alone to do things that are beyond their competency level, and I think we, again, talked about this a bit at the conference already. We also want to protect innovative research. So if someone's got a great idea, what we don't want is for that idea to be suppressed or pushed aside because that doesn't fit with the status quo. We don't want someone to falsify their results because it doesn't fit with what's expected. And again, sorry, and this is just going to sound repetitive, but it does link to open science. Protect public trust. So I think we've covered this fairly comprehensively in the conference so far. But if you're taking public money and you're producing research that people are going to base their decisions and their lives on, then that research better be reliable. It better be worthwhile. It better be truthful. Yeah? And protect future research from the consequences of misconduct, which I think I've said about the knowledge base. This is the thing. So it's about consequences and about caring about things. But this is all very well. So I stand here and I say, we should all be wonderful, you know, good people. We should be good Boy Scouts and brownies, whatever the equivalent Boy Scouts is. You know, and it sounds very well. But when you're working on a research project, how do you actually go and do that? So how do you embed that? So these are some of the challenges that we face with research ethics and integrity. So how do you ensure that all research undertaken in a large EU project is ethical? Much as I'd like to, I cannot go around with a little badge kicking down doors in laboratories across Europe, checking everybody's doing ethical research. I say I'd like to just because it sounds really fun. I just mainly want to kick down doors. Okay, so how do you monitor and audit the research ethics from countries with differing ethical governance processes? So in, I think, France, for instance, they have a national data protection authority, whereas in other countries that they don't do things like that. They have institutional level data protection officers. So when you're asking for data protection ethics, how do you match those two things up? And this is something the ethics reviewers actually asked us for. So they actually came to us and said, you've got to show that every single researcher that's doing anything with data protection has been approved by these authorities. And we kind of said, well, these authorities aren't uniform. Well, you know, this is a problem. And how do you embed research integrity? On a similar theme there. Okay, so ethics in the Human Brain Project. So these things here are the 9 categories that appear in the ethics self-assessment for Horizon 2020 research. So research on human embryos and fetuses, research on humans, research on human cells and tissues, research involving personal data that can lead to a violation of data protection rules, research on animals, research involving non-EU countries, research affecting the environment and health and safety, dual use and misuse, which we've heard lots about. So these are the 9 categories, and these are some of the ethical issues that appear in the Human Brain Project. So under humans, we have consent, particularly informed consent for, say, medical, but also for just interviews, psychological tests, whatever. Incidental findings. So I think we've talked about that a bit, but that's, you know, if you're doing an experiment and you find something you weren't looking for, so you're doing a scan of the brain and you find a tumor, do you tell the patient? Does the patient want to know, or the participant want to know? You need to find that out before you do the research, not afterwards. Privacy. So this links to data. So Lise this morning talked about people's concerns about privacy. Animals, so obviously the 3 R's, reduce, replace and refine. Non-human primates, we actually looked into that after the little debate and found out they were monkeys, not chimps. My apologies. I think they wanted to use chimps, and it was like ages ago, and then that was muted because it's not allowed. So I think that was a conversation that kind of got lost somewhere in the mists of time. And the welfare of animals, which I think, again, those who went on the lab visits, I think have had a sort of face-to-face experience with. And then data, so storage, source, and acquisition. So who's storing the data? Where are we getting data from? So one of the things is we can't use data from non-EU countries if they can't prove that the experiments they did to get the data couldn't have been done under the same ethical regulations as in the EU. So we don't accept data from, say, China. An acquisition. So who's acquiring the data? Can they de-anonymize it? What are they using it for? These kind of issues. So, big scary slide with a flowchart. That's exciting. Okay, so 120 partners in the Human Brain Project now, and growing, because we've got partnering projects, and 370 separate tasks. So we have 12 sub-projects. Each sub-project has work packages. Each work package has tasks. 370 tasks, and I have to know the ethical status of every single one of them at all times and to report it to the European Commission, which is a challenge, as you might imagine. So we came up with this flow diagram. You don't need to actually read the flow diagram, though you're quite welcome to. But our basic process is here. So we took that self-assessment, but it's a static document, it's a PDF. And we turned it into an interactive online survey. I say we, before I started on the project, that was done, but then I made it better. Not to brag, but I did. So the tasks leaders can complete that online. So if they say no, that they don't fit into any of the categories we saw on the slide before, they can go on their merry way. That's fine. We can put none as the ethical issues. That's fine. If they say yes, they get a copy of their email and an ID number, and we have a spreadsheet that's auto-populated, so we have a record of it, and I can just search by task, right? And then they're asked to upload or email copies of their ethical approvals that they have got from their institution. And that is all stored in Trezor, which is basically a much more secure version of Dropbox, which is hosted in the EU, so we're not hosting data outside the EU. Yeah, and I'm going to talk a little bit more about the EAB and Paul, but we also have an internal review process to ensure that what they're saying on the survey and what they've sent us actually match up. So if they're saying they're doing something on mice and they've actually got approvals for rats, that's no good to us. So we have a check system, basically. And this works pretty well. We've got a good response rate now. We've tweaked over the last 4 years, and we're getting somewhere where it's quite a smooth running, which is good, because one of the things about making the tick box side of ethics better and smoother and less time consuming is you can then use all that time that you freed up for you and the PIs and for researchers to actually work on the bigger stuff. So if you've done the simple ethics, going back to the chap yesterday was talking about overthinking things, right? If you don't have to overthink getting this done, getting reporting to the EC, then you can start overthinking the stuff that needs overthinking. You can start thinking about the consequences of robots and consciousness and, you know, animal research. So that's why I think this is actually important. There's a difference, I think, between compliance and caring. So part of my job is to ensure that people are compliant with legislation, and that's important because the legislation is there to stop everyone just, you know, we don't really want the Wild West version of research. That might be fun. But what I can't do with compliance is make people give a damn, frankly, about the ethics. And this is where some other ethics support mechanisms come in. So we have a point of registration. That's Paul, point of registration. I didn't come up with that. But that's where people, and I think Christine mentioned this right at the start, can raise ethical issues either from the members of the public, someone who's participated in a research trial, or from inside the Human Brain Project themselves. They can do this anonymously if they wish, and it comes to us at the ethics management team. And if it's simple, we can just respond. And if it's more complex, it goes to the EAB, which I'll talk about in a moment. So the rapporteur network, so that is, as Christine explained, a reversal of putting ethicists in sort of research projects. It's getting researchers from those projects to think about ethics, and we've just had a series of trilateral meetings. So the EAB, rapporteurs and ethics management had teleconferences, and we talked about what issues were needed to be addressed in each sub-project. And then the Ethics Advisory Board is probably one of the most important things. So these are independent of the Human Brain Project, and they discuss ethical problems. They help us decide how to respond to ethics reviews. So the EC may say, we need this, and they kind of say, well, we could do it this way. They bring a great deal of expertise and are wonderfully organized by Shabin. So these are some of the ways we help researchers care about ethics as well as just be compliant with them. Right, so the website is currently undergoing some major kind of changes. So this is coming a coming attraction, not a present attraction. But there will be a standard operating procedure. I know that's an exciting phrase, but there'll also be a fact sheet, so you don't have to read 20 pages. So that'll be available on the website for research integrity. It's based strongly on the ALIA European Code of Conduct. Obviously, queries can be sent directly as well as through POR. Websites are there. But the most important thing is that we're going to, on the website, build a ethics resources hub. So this is going to have videos, this is going to have checklists, this is going to have interactive kind of quizzes and stuff, resources, and in that there's going to be stuff on research integrity, there's going to be stuff on ethics. I'm really hoping that we can kind of make this happen and make it somewhere people can go and you know, particularly junior researchers can go and kind of learn about the ethical issues in the Human Brain Project, but generally as well. So that's going to be uploaded soon. So yeah, just to recap, ethics and integrity in the Human Brain Project, these are the people involved in ethics management, and this is a summary, kind of just what we do. So the ethics compliance process, rapporteurs, SOPs, and so forth. So now for some interactivity. The dilemma game. So this was came up with by the University of Rotterdam. And there are no right answers. So just to repeat, there are no right answers. There's no point asking me, I don't know. It's what you think is the least worst thing to do. And it makes you think about the challenges researchers have faced, maybe that you faced, maybe something will ring true. And it shows you the shades of grey in research integrity. And indeed ethics, but this is more about professionalism. So what I'm going to do, don't worry, you don't have to hold up cards or you know, whatever. You can just shout it out. It's going to make your life easy, isn't it? You have to run around with the microphone. Yeah, so just I'm going to put them up. Have a think about them. Talk to the person next to you about them for a couple of minutes. If you want to comment on those, please do. If you just want to think about it in your head, that's fine. I don't force people to socialize. And there's about 4 of these, and then we can just have a general discussion, or we can move on, whatever you like. I'm not, you know, precious about this stuff. Okay, so first one. During a particular research project that I am participating in as a PhD student, the project leader has many projects going on at the same time. We are mainly supervised and coached by senior PhD candidates or postdoc researchers. When I want to publish an article, the project leader asks me to put his name first. When I respond negatively to his request, he becomes angry, saying, "It was not a question, please consider the position you're in." What do I do? A. Say nothing at the time, but discuss the incident with some senior colleagues. B. I tell him that he should consider his position and stop right now. I threaten to report his misconduct. C. I let him have it his way. He will probably return the favour at a later stage. D. I tell him that I did not mean to offend him. I ask whether it is acceptable for him to be second author and explain how much the first article means to me. Discuss. Or not. Okay, so does anyone want to feed back any ideas, or did you just want to keep your thoughts private? Say something. Yeah.
First of all, thank you so much for an interesting presentation. We were discussing with our member of the team. I think I will tell to my supervisor, this is my patient disease and I would love to be first author, and I will ask him if it's possible he be second or the last one as a corresponding author. But at the same time, I will discuss, as Mr. Shin said, with the senior researcher to see is that going somewhere or no. If I take my thesis and go everywhere from this office to another one, graduate school to the others, does it make my process longer and getting nowhere and wasting time and energy, and then lots of angers behind my thesis or not?
Okay. Yeah, great. Yeah. So maybe combination of A and D. No, great. Yeah. I don't like having.
Emma, did the student write the paper?
Yeah, I'm gonna go. Yeah, they did. Yeah.
And it has to count as one of the papers for getting to graduation.
Yeah.
Only if you're first author.
Yeah. So,
You can be second author and it counts for your dissertation?
For some universities, you don't need to publish.
Oh my gosh.
The PhD requirements change according to the university or the graduate program you're in. For some, you need to publish maybe one first author paper and one any other author paper. For some, you don't need to publish at all. For others, they ask for 3 publications. For some, they ask for a quartile of 1 publication. It depends on the graduate program.
okay. So it's context specific. Yeah.
When I was saying, I forgot to say, this is very unfair on our professor or supervisor or senior researchers in our team, because when I think without their knowledge, the guideline, they are leading us. It's unfair we say you did nothing. What that protocol comes from, the bunch of articles and papers and research projects behind his or her background, so we cannot say, hey, you did nothing, I'm going from blah blah blah, this student to another one, make a big team against that professor and supervisor, because one time myself will be in that position, hopefully, this is my dream. But, so you don't want to ruin the reputation of the person who has spent many years to be there. So I think it's unfair to...
No, I think that's yeah, very a very important point, that the professor is not necessarily the bad guy, or you know, that they may have contributed in a less obvious way. I think being first author is a bit of an ask, to be personally, but yes, to be credited on a publication would not be, I think, completely at the realms of. Yes.
So I think the credit in terms of authorship for a paper has to be based on some substance, which is why I asked the question about who wrote the paper. And you know, I think the other questions are things like who conceptualized the research, you know, what the PhD student did in terms of the substance of the research and the data and the analysis and so forth. And those are the things that have to be given as reasons for why you would be first or second or third author. And, you know, simply saying it means a lot to me to be first author, well, I understand that it could mean a lot, but it has to actually, the credit needs to be connected to some substance.
So it has to be substantive contribution, I think is what they call it. So I think it's the IMCJ, maybe? I might have mangled that an acronym. Yeah. Guidelines, they're quite strict. And yes, please talk about the book. I was gonna get onto that.
Well, I would point out to this character that the Inter-Academy Partnership, i.e. the global union of all the national academies that can, recently published Doing Global Science. And I think as a short thing for young researchers to read, it's about the best I've ever seen, in the sense that it goes through each stage of the research process, from thinking about it to publishing it and beyond, in a very sensible way. And I would just say to this senior idiot, please go away and read chapter 8, which is about reporting research results, and have a think about it.
There we go.
Because all of the kind of issues that arise, not all of them, but most of the issues I've ever come across end up in chapter 8.
Yeah.
And if you read it, you can see the kind of point that you were making. There has to be some reason why people or names are on the papers. And there are different ways in which you can order them, but you need to agree that between them.
Absolutely. Thank you very much. Yeah, I'd recommend everyone reads that book. It'd probably put me out of a job, but you know.
It's on the web, freely available, and it's well worth spending an evening reading it through.
Freely available on the web, everyone. So yeah, save yourself some time and just read that. I can retire in the Bahamas. Yeah, sorry, Abdul, go on.
Comment. The project leader, they're asking to be the first author. Normally, usually these days, the project leader they can be last authors.
Mm.
In this case, both the students and the project leader would, they would get something out of it. So usually the senior authors is kept as the last author, isn't it? Most of the publications.
Okay.
So in this case, both the student
Yeah.
and the project leader would have something.
Okay, so both could have something. Great. Okay, let's move on to the next one because I'm aware of time. Thank you all for your contributions. So, the paper I worked on very hard is nearly finished. Next week is the deadline of the special edition of a prestigious journal. My student assistant then shows me an article that looks very similar to mine. A model that I present as new in my article has apparently already been published. Luckily, it was published in a lesser-known journal. Do I? A. I pretend to have never read the article and do not mention it in my own article. I hope the reviewers of the journal do not know the other article either. B. At points in my article that overlap with the other article, I refer to the other article. There's too many other articles in that sentence. Thereby risking my paper being rejected because of lack of substantive contribution. I refer to the other article to a very limited extent so that my article appears to be original. I drop the paper and focus on another project. Discuss.
So a colleague of mine had the exact same dilemma.
Okay.
I went with B.
You went with B. Okay.
But the paper didn't get published. They're still trying.
Right.
But
Okay.
they're going very low impact now.
Okay.
So, you know.
So there are consequences.
There are. But
Yeah.
it felt like the honest thing to do.
Okay.
There was a lot of, you know.
So they went for integrity over career progression.
Yeah. Yeah. This is the University of Sheffield. Just want to say.
Yeah. You've got good research integrity.
What kind of paper was it?
I
don't want to allude to the particular researcher, but it was neuroscience.
So there are different options for different ways of handling it. But if it's reporting from the same data set and someone did an analysis and got it published before the same analysis that you did, you're kind of stuck. But if it's a matter of interpreting something in a different way, and this published paper has given you information that actually advances your thinking, you can continue with that paper and put new thinking into it that then continues a conversation in print. So it depends on what the paper is about, what options you have available.
So in this particular instance, they knew the lab that did the work and had a feeling that they kind of poached their idea a little. So a lab in the States with a lot more money and a lot better resources who did everything a lot more quickly than them. So they couldn't really compete. So they just basically had the same idea but did it better actually because they...
If they are sure about that things you mentioned, they can, report that to the head of the faculty, and the faculty will contact journals.
But they can't prove it.
There's no proof because it was verbal discussions. So
Yes, this is one of the issues I have with research that used to come to me with research integrity. So someone stole my idea. Okay, right, that's plagiarism, fine. Where did they steal your idea from? Well, I was talking to them in the pub. Yeah, that's not going to wash, unfortunately. You may be right, they may have, but, or even in a teleconference or something, unless it's minuted, and it's sad because you don't want to make you don't want to be guarded. I think we had this conversation at the meal last night, right? Oh, sometime. But you don't want to be guarded. You don't want to sort of be watching over your shoulder. But at the same time, if it's verbal and someone takes your ideas, very little you can do to prove that. Hi.
But I also think because this is really like a sketchy area, right?
Yeah.
Because one thing
Very
is having
sketchy.
an idea, but another thing is acting on it.
Yes.
Right? So at any one moment, a bunch of people might have similar ideas, but only when you actually carry it through and write it down and do the research does it become something, right?
Yeah.
So I am a little bit against this whole culture. I'm hoping that will really change this about like this is my idea, also because
Yeah.
exactly that it happens the conversation and you know the creativity that arises when you talk to other people.
Absolutely.
And also, if he, for example, talks to someone in a pub, well, maybe part of his idea developed through that conversation. So isn't it everyone's idea?
Absolutely, yeah. So we heard at the last talk about getting away from this culture of my idea. And again, this is why I'm saying that integrity and open science are good bedfellows. They are, one is in a way a solution to the other. I'm aware I'm running out of time, so I'm just going to go through to the next one, which is a really quick one. When screening my data, I find there is one extreme observation. What do I do? Nothing is part of my theoretical sample for a reason. I look for information on the observation, trying to find qualitative reasons for the deviance. If there is a good explanation for its position, it must be a niche observation. Since it's part of my theoretical sample, I leave it in. However, if there is no explanation for its position, I leave it out, as it either due to a measurement error or response bias. C, I look for information on the observation, trying to find qualitative reasons for the deviance. If there is a good explanation for its position, it must be a niche observation. Despite my theoretical sampling, there is no place for such anonymous observation, so I leave it out. If there is no explanation for its position, I leave it in to avoid potential sampling bias. D, I let a colleague review the data and follow her advice, whatever it is. Any thoughts? That was quite a complicated one. So basically, if you find an outlier in your data, do you ignore it or do you include it? Let's just do that. This is complicated.
Not D.
Yeah. Don't just blindly follow. So that's.
So one of the choices, Emma, was not actually collecting more data. If you're doing qualitative research.
Yes, or run the same data again and see if it comes up. She's just going to yell at me. It's fine. So do more, collect more data, or run the data again, and see if that would. So you've broken the quiz. Well done, Christine. And finally, last one. To alleviate the stress for children, it is better to take extra biopsy for scientific purposes during a regular biopsy that children undergo to confirm diagnosis. As researchers, we are actually only interested in the biopsies in a few cases. A colleague suggests that taking the research biopsy during the regular biopsy and telling the parents afterwards when we find the biopsies are relevant for research purposes. Normally, it takes some time to explain the procedure and fill out the consent form beforehand. What do I do? A, I take the biopsies during the regular biopsy and ask for parents for the consent afterwards. B, I do not take the extra biopsies during the regular biopsy, but I ask for consent from parents in the relevant cases after the diagnosis before I take the extra biopsies. In any biopsy, I ask parents for consent before doing regular biopsy. I tell my colleague that, in my opinion, the suggestion is unacceptable, and I want to know whether he has done this before. So this is about informed consent. We talked about this. So this is kind of, I know where I sit on this. It's D, by the way. Just, sorry, spoiler alert. Because I think doing anything without informed consent is deeply unethical. I see the point, but you can't do that, in my opinion. But does anyone have any conflicting views? No?
So, Emma, what do you think about C? Because I think C is common practice and it's not very justifiable.
In any biopsy, I ask the parents for consent before doing the regular biopsy.
So the idea is just to get as many tissue samples as you can, especially since you're going to put them now in a big tissue depository, and they might be used for all kinds of secondary research. And so there's a big drive to get consent for every biopsy and take as much tissue. Right,
yeah, okay. I don't think it's a terribly good idea, because I don't think people may, especially in that stressful situation, so their child is being diagnosed for something, and you shove a piece of paper in front of them and they go, okay. And I'm not entirely sure that it's entirely thought through in the right way. On the other hand, I understand the desire to have as much samples as possible so that you can do as much research as possible, so that when you diagnose a child with some terrible disease, you can maybe have a better chance of curing it. So it's one of those individual harm versus greater good questions. I guess I don't like it. but I don't really like animal research either, but I accept that it may be necessary. I think there are probably better ways of doing it. I just can't think of them off the top of my head. I think there's probably a more sophisticated way of doing that than just sort of mass consent kind of things. Maybe an ongoing relationship with the patients and the parents. So instead of you just take the biopsy and then they never hear about it again, some kind of, maybe feedback on what happens to it, some ongoing asking for consent so they can opt out at some point, maybe something like that. But I don't know. That's just off the top of my head. Yeah. Oh, hey, Malcolm.
Just one general reflection on the last 3 examples.
Yeah.
And obviously on the first one.
Sure.
Whatever you do, keep a written record of this.
Yes.
Of what was going on, and what you decided to do, and who you told what.
Yeah, absolutely. Yeah. So one of the major ways to avoid these issues is when you're planning your research, decide who's going to get the publications, like beforehand. Don't wait till you've all finished the research and then start trying to divvy up credits. If you enter into some kind of dispute, copy everything into an email and keep the emails. Don't just have a verbal conversation with someone, and if you think someone's committed research misconduct, don't kind of go and investigate yourself. That's even though I understand why you might be, you might want to make a big fuss. I completely understand that. I'm not a person that wants to make a big fuss about things either. But if you start ferreting around, you're going to put yourself in a very vulnerable position. And the best thing is probably to talk to a senior colleague that you trust, who can maybe advise you about what the situation is and what their take on it is. But yeah, written record. In life generally, get a written record. So don't do things by verbal agreement. The famous thing, a verbal agreement isn't worth the paper it's written on. Get records of everything. Keep records of everything. And open science, which will solve most of my problems. Okay, that's it really. Thank you ever so much for listening.